Hi everybody, in this one let's take a look at deriving some identities for example, expressions that look like this one, sine of s plus t, or maybe something like, for example, cosine of s plus t. We're going to use complex exponentials because they make the process go very easily. So in other words, I'm going to use an expression that looks like e to the I, for example, s, or e to the I t. That's our goal here. So first of all, let's define the following, that e to the it, now I is the imaginary unit, and then t, for example, is your angle. This is basically equal by definition to cosine of t plus I sine of t. Using this fact allows us to derive expressions for sine of s plus t, or for example, cosine of s plus t. You can also do this with sine of s minus t and so on. So let's begin. First of all, I need to have a quantity that looks like this, e to the I and then s plus t. And why do I want that? Because my expression says sine of s plus t. So that would naturally enough, if you follow the basic model, look like cosine of s plus t and then plus I sine of s plus t. So that will give us this part, this will give us that part. Now we just need expressions for those. And we can get that by recognizing the fact that this part on the left side there, I can rewrite that as follows. I can write e to the I s times e to the I t. And that's because of a basic rule of exponents. Remember, for example, like 2 to the 3 plus 4, that's equivalent to 2 to the third times 2 to the 4. I'm writing on the side here. It's equivalent to that. So you can either go this way, or if needed, you can go this way. So in our case, I have s plus t within the parentheses at this step right here. I have s plus t. So I'm going to e to the is times e to the it. Take a look. What does that give us? First of all, e to the is I can now write in its complex number format essentially as cosine of s plus I sine of s, bracket, and I'm going to multiply that by e to the it in its complex number forms. That's going to give me the following. Take a look. For example, cosine of t plus I sine of t, just the way you see it. And then from here, we can just FOIL things out, gather, and you'll see what happens as a result. So let's FOIL things out a little bit. I'm going to take this and multiply by this one. That's our first FOIL step. So I'm going to have cosine of s multiplying cosine of t. Then I'm going to do the next part, which will be cosine s times sine of t with the I in there. So I'm going to have plus cosine of s. And now let's be careful. It's going to be an I, so I'm going to put the I out here. And then sine of t. And I continue with my FOIL process. So I'm going to get that next. So that's going to give me the following. Plus I again. So the I is coming from here. Sine s and then cosine t. And then lastly, let's repeat this one last time. So then next I'm going to do this one. That's the last one. That's going to be, again, there's an I from here, from in front of the sine. So it's going to be plus I sine s times I sine t. Times I sine t. All right, now we just have to simplify all of this and recognize what we need from it. So specifically, cosine of s, cosine of t. These two things in the middle, one has cosine s right here, cosine s sine t. This is sine s cosine t. And then the last one says I sine s times I sine t. That last one where I'm tracing, we can multiply everything out. So it's going to look like this. Take a look. Let me copy. So I cosine s sine t. And from the middle terms right here, what I'm going to do of the ones where I'm tracing is just factor the I out. Okay? So that means the following. I'm going to have cosine s sine t plus sine s cosine t, like that. I factor the I out from the two middle terms. And the last one, well, I have I times I. That's going to give me an I squared. I squared is negative 1. So that last part becomes negative 1, multiplying the sine s and the sine t, just the way you see it. Now I can gather everything like this. Cosine s, cosine t, minus sine s, and then over here sine t, plus I, and then that entire expression within the square brackets, cosine s, sine t, plus sine s, and then cosine t. Go back to the original. The only way two complex numbers are equal is if the real and imaginary parts are equal. So what I mean by that is the following. Back over here, where I'm just tracing, highlighting, I have cosine of s plus t. That's the part of the complex number that does not have the I in it, which means down below, that has to correspond to this in value. Take a look. Further beyond that, let me highlight another bit here. Let's also do one in yellow, for example. So for example, this part, sine of s plus t, the one with the I, naturally enough, that has to correspond to this part right here. So what this allows us to say now is the following, that basically cosine of s plus t of two separate angles, so the cosine of a sum, say, of two angles, is equal to the blue part, which is cosine s, cosine t, minus sine s, and then sine t. And I hope you understand why that negative is present, which is coming from over here, if you remember back when we did this step right here. Right, when we did I times I squared becomes negative 1, so introduces that negative right there, which then carries over down to here. Let's also write down this other rule that we can derive from this, which is that, for example, sine of s plus t is equal to cosine s, sine of t, plus sine s, and then cosine of t. Now I've shown you how to do this specifically in the case of the following. When over here I'm doing e to the I s plus t, I break that up into a product of exponentials. I replace this exponential with its definition using complex numbers. I then FOILed, I gather like terms, and I equate the real and imaginary parts down below. I did this with s plus t, but you can do very much a similar thing using s minus t. And you're going to get a couple other rules for s, for example, minus t over here, and then sine of s minus t over here. So that is it for this one. Thanks so much for watching. Let me zoom out. Hopefully you can see the whole thing from top to bottom. I'll see you in another video. Please leave a like,